Is it started?
Yes, sir.
Yeah. Okay, good. So if you, as we were discussing, the sources of errors for total station, instrument-based errors, natural error, personal error. So if we take a deeper look into the setup, whatever we will see today probably in the lab, the total station is one of the very sophisticated instrument for field data collection for engineering survey purposes. It can calculate, it can measure some of the primary parameters, angular and some length parameters, and of course calculate and compute the derived parameters or observables. So horizontal axis is the line along the telescope, which is the axis of sight, which is along which the telescope is focused. Then axis of the plate level file. So this is the axis of the plate level file and the vertical axis. So we need to be bothered about all these three components very carefully so as to minimize the errors. So this figure shows the fundamental reference axis of the total station. As discussed earlier, a properly adjusted instrument will have minimum error, and these axes must bear a specific relation to each other. So the vertical axis should be perpendicular to the axis of the plate level file. The horizontal axis should be perpendicular to the vertical axis, and axis of sight and the line of sight should be perpendicular to the horizontal axis. And if these relations are not maintained, not the Boolean thing is not true, errors will result in the measurement of the angles unless proper field procedures are observed. And the misadjustment of these axes and other sources of errors will result into instrument related errors. Okay. So the first type of the instrument error. So, okay. So actually this comes under instrument error. So under instrument error, we have several other small errors. Let us minimize this. So the plate bubble out of adjustment. So if this occurs if the axis of the plate bubble is not perpendicular to the vertical axis. Probably those who have handled the instrument, they know that the bubble is there, and then we have the spirit level of two types, linear type and a circular type, and the plate bubble is not perpendicular to the vertical axis, then the latter will not be truly vertical when the plate bubble is centered. And this condition will cause a lot of errors in the observed horizontal and vertical angles, which cannot be eliminated by averaging direct or reverse readings. Okay, so what happens in the process is, no. Okay, so what happens in the process is some geometry which comes up like this. So with the telescope, actually the plate bubble out of adjustment is out of adjustment if after centering it returns to it runs with the even after centering it runs when the instrument is rotated 180 degree in the azimuthal direction. So the angles are misoriented. So the situation is something very similar to what is depicted here. So the blue dotted line is not actually falling in horizontal surface, with the telescope initially pointing to the maybe right, and the bubble being centered. The axis of the level vial should be horizontal by as detected by the bold line, not the dotted line, ALV1, this one. So this should be the ideal condition. And then the ideal condition is not getting met because the level file is out of adjustment. It is not perpendicular to the vertical axis of the instrument, but instead makes some 90 minus alpha degrees with it. So this is the angle which it makes with the vertical axis. Okay. And after turning the telescope 180-degree, it points left, and the axis of the level file in the position indicated by the dashed line AVL2 is the orientation of the telescope. So the angle between the axis of the level file and the vertical axis is still 90 minus alpha, as shown in this, and it's indicative of disleveled, misleveled, or the bubble out of run, and is E. So the capital E is where it is now. So from this geometry, we can see that this capital E is equal to twice of the alpha, which is coming from the basic geometry. Double the bubble's misalignment error or misalignment angle. So vertical axis can be made truly vertical by bringing the bubble back by half of the bubble run, so and using the foot screws so that it is properly aligned. And then even though it's not centered, the bubble should be staying in the same position as long as the instrument is rotated in the azimuthal direction, and accurate angles will be observed. Okay, so although the instrument can be used to obtain accurate results with their plate bubbles misaligned, it is inconvenient and time consuming, so that the record adjustment should be made quickly. Okay, as earlier we discussed, so we should again set up the tripod, go for proper centering and all those. So some total stations may be equipped with dual axis compensator. This is where they are very important, which are able to sense this amount of misalignment and the direction of vertical axis tilt automatically. And this circuit is very interesting, and this circuit has been developed as a prototype by some of our students in surveying in earlier years. That's where you gain a lot of interest in modern day equipment, from lots of positioning, imaging and other devices which you are being taught now based on the applicability. A lot of applications are coming up in present day where geospatial data, geoinformation, geoimage processing are coming up directly into the daily life. So I can only urge that you can take up one or other such small tasks of your own. And a lot of them are there available in a lot of, Google search, where you can get automatic low cost compensator designs, or someone who is good in programming, someone good in, integration of hardware and the software system integrations, embedded systems, so they can generate benefits, interest slowly. So instruments which are equipped with single axis compensator can only correct the vertical axis, but those who are having dual axis compensator, they can do both. Okay. And the compensation, automatic compensation is very you know delicate part of the recent idioms. Okay. So total station instruments with dual axis compensator can apply these mathematical corrections to horizontal angles, which which accounts for any leveled or misleveled process of the horizontal and vertical axis. If we take a look at this is the theory part, what is going on inside the instrument from geometric perspective. But if you look at the actual setup from the instrument point of view, so this instrument projection and the geometry that is getting formed, this is the domain knowledge which comes up in helping the development of geometry of the instrument for misleveled calculations. So to sight on point S, the telescope is plunged upward from the instrument station, and because the instrument is misleveled, the line of sight subscribes an inclined line SP dash. You see SP dash. Is it visible, friends? SP dash instead of the required vertical side line SP. And the angle between these two lines is the alpha, the amount that the instrument is misleveled or not properly leveled. And from here, we can see the EH. EH, you are able to view error in the horizontal direction, capital EH. So EH is alpha tan nu, and nu is the altitude angle at that point. You can see the altitude angle at that point. Okay. Point S, 2-point S. Is it clear? Are the parameters getting captured by each one of you? So this is the instrument station. This is where the telescope is being sighted. Instead of being projected to SP, it's getting SP dash, and then the angle projected, the angle between the projected line SP and SP dash is getting captured as alpha, when this is creating an error in the horizontal angle of EH. So, okay, let me see if I can, yeah. So EH is alpha tan nu, and nu is the altitude angle for point S. Okay. So this calculation is very important so as to minimize the errors in my misleveled or wrongly leveled instrument. Any doubt, class? Akash?
Sir, did not understand the diagram.
Which diagram? There are so many diagrams I have explained. Which diagram you did not understand? The
This
last
one.
one.
Yes, sir.
Last one. Okay. Aman, did you understand the last one, or what is your doubt? You keep telling. So instead of me asking one by one, if you have doubts, you can start writing on the chat. So don't worry. Mm, you are not there for the. You can actually go for the. Mm, you can actually go for putting your doubts on the chat. Amlipur, Amlipur,
Yes, sir.
is there any doubt?
No, sir.
Let me know how many of you have doubts. Please raise hands. Like Akash has doubts. Akash, please raise hands. Let me know how many of you have raised hand. Yeah. Okay. So four. So what is your doubt? You please write in your chat. I'll catch up. Please write in the chat so that I know that this is the doubt. I'll come to the chat quickly. Okay, so from this equation, EH equal to alpha tan nu, nu is the altitude angle of point S, which is being observed. And for the observation of any horizontal angle, if the altitude angles for both the backside and foresight are nearly the same, the resultant error in the horizontal angle becomes negligible. And in flat terrain, this is approximately the cause of error due to improper level, so misleveled setup, but it can be small. So, however, in mountainous terrain where the backside and foresight points can be can vary and can be varying by large amounts, this error can become substantial. So, if an instrument that has 20-second out of level reads a backside zenith angle of 93 degrees, then the foresight zenith angle and the foresight zenith angle is 80 degrees, the horizontal error in the backside direction will be alpha tan nu 20 seconds tan minus 3 degree, and the foresight will be 20 seconds tan 10 degrees. And this cumulative error in the horizontal angle of 3.5 degrees minus this minus of 1 minute. So at least 3.5 minutes, and the negative error which is coming in the foresight, so approximately 4.5 seconds. So this is symmetric error that becomes more serious as large vertical angles are observed, and it is critical in astronomical observations, especially where we have the azimuthal angle to be taken into account. Okay, so let me check if there is any chat message. Did not understand this diagram. Sort of. Okay, so only one query, so I can explain this once again. Okay, so this is the setup for this is the setup for the instrument, and the telescope is pointed towards the point S, which is the observation station, and I am having misleveled instrument here, which is not properly leveled with respect to the horizontal angle. So by geometry, this line of sight between the instrument and this point S should be projected to SP, and this will be the actual triangle. But because of the misalignment, I have the SP dash, which is because of the misaligned or misleveled instrument. So the angle between the two lines becomes alpha. So because of this, these two geometries are getting into consideration for all calculations based on my total station, because it's also following a level which is not properly aligned. The horizontal angle difference, which results because of the positioning difference of point P and P dash at two different orientations. P is ideal one, P dash is what is coming up because of the misalignment. We have EH as the horizontal angle error, which is related as alpha tan nu. And this nu is the altitude angle of point S. So once we know this, we can compute, or we can eliminate the horizontal angle errors to a much greater extent. Is it clear, Saurav?
Sir, what is alpha? Misalignment.
Yeah, alpha is the misalignment, mislevel, leveling, and because of not proper leveling, we will have different verticals,
Yes, sir.
perpendiculars dropping from S to the level ground, horizontal ground, and this will be the horizontal ground by the misaligned leveling at the instrument, isn't it? So the same geometry is being followed for all the optics part of the instrument. So instrument will have the misaligned, misleveled geometry, but the actual geometry has to be met. So that's where the error comes. Is it becoming clear?
Yes, sir. And so what is E?
Error in horizontal angle. E,
But
which
alpha is misalignment, then that is only the error. Like,
no. You have to consider the 3D. There are derivations. You take it. We will discuss if you have some more, discussions. Personally, message me. I will solve. Okay. So as of now, we all proceed because there are well-established derivations coming up from both the domain experts and the instrumentation components. So the relationship between error in horizontal angle with respect to any location whose altitude is new is alpha 10 nu. Okay. So
sir, so
your
is this
your
in like,
doubts, your
is this
doubts,
something
yeah.
kind of prism?
Hmm? Yeah,
So
tell
this
me.
diagram, sir, this diagram is a kind of prism.
No, not
Then
it
three.
cannot be. It's on undulating ground. So it is not the prism.
Like, if we make EH as error in horizontal angle, then that will shift. The new dash line will shift in other direction. So it will make kind of prism only.
It is the actual geometry happening in the landscape. Say this is the hilly terrain. Okay, so uh, the corrections that are coming up are to follow this geometry, and that's where we need to level it properly. Okay.
Okay.
Hmm. So the major problem with the instrument error is the plate bubble out of adjustment. Okay. So the plate bubble, as we say, needs to be properly leveled, and this is one of the very first tasks of setting up. Okay, clear, friends?
Yes, sir.
Hmm. Aditi, you are late. Why you are late? Okay, so let us go to the next error source. Horizontal axis not perpendicular to the vertical axis. So this situation causes the axis of sight to define an inclined plane as the telescope is plunged, and therefore if the back sight and foresight have differing in angles of inclination, incorrect horizontal angles will result, and errors from this this type of sources can be cancelled by actually averaging equal number of direct and reverse readings. However, we need to know uh, if this is really having some error or not, and if uh, we have the knowledge, or that's where the proper field procedure is used, we will go for equal number of direct and reverse readings, and we will go for minimizing the error as far as possible. And with total station having dual axis compensation, this error can be determined in calibration process that consists of carefully pointing the same target by both direct and reverse mode. And once that calibration is being done, so this error will be sensed, and this operation will be captured in the microprocessor circuit and the program, which can compute and store the correction factor. And this automatically gets applied to any other subsequent horizontal angle that are recorded. So horizontal axis not perpendicular to the vertical is also compensated in EDMs like total station. Next is axis of sight not perpendicular to the horizontal axis. So axis of sight means the line of sight through which we view, that is the telescope. So it's the center line of the telescope. If this condition exists as the telescope is plunged from the instrument station to the observed station, the axis of sight generates a cone, which we told in the class earlier and even in the laboratory class, whose axis should coincide with the horizontal axis of the instrument. And the greatest error from this source occurs when the plunging of the telescope as in a prolonging a sight line or measuring a deflection angle, so that becomes most. And when the angle of inclination of the back sight is not equal to that of the foresight, the observed horizontal angles will be incorrect. And these errors are eliminated by double centering or by averaging equal number of direct and reverse readings. So the field procedures are actually defined so scientifically and systematically that the errors, each of the errors which come and occur in our normal conventional instrument gets auto detected, compensated for, and following the procedures of field data collection can be eliminated. Okay. The next error is the vertical circle indexing error. When the axis of sight is horizontal, an altitude angle of 0 or a zenith angle of either 90 or 270 should be read. Otherwise, the indexing error exists. So we have seen it earlier also. So these indexing errors become a big source of, data getting erroneous, which are getting collected. So the error can be eliminated by computing the mean from equal numbers of either altitude or zenith angles read in direct and reverse mode, which we saw in one of the numericals which we solved. And with most of the newer total station instruments, the indexing error can be automatically determined by carefully reading the same zenith angle both by direct and reverse mode. And the value of indexing error is then computed by the firmware which is there in the microprocessor and stored and automatically applied to any further angular readings which are captured in using the same setup, using the same instrument during the field survey. However, the determination of indexing error should be done carefully during calibration to ensure incorrect calibration error is not getting propagated in subsequent angles observed with the instrument. So vertical circle indexing is also taken care of. This fifth error is the eccentricity of the centers. So this condition actually exists if the geometric center of the graduated horizontal or vertical circles do not coincide with the center of rotations in either horizontal or vertical axis. So we need to move the telescope on a vertical axis and we need to move the whole of the instrument from one observation station to the other in the horizontal axis. If the axis centers do not overlap in both horizontal and vertical directions, we'll have eccentricity based errors. And total stations uh, actually are so robust that these errors are very less. However, if you handle it rough, then these errors will be there. So we try to take as much precaution as possible. And total stations may also be equipped with systems that automatically averages the readings taken in opposite sides of the circles and thereby compensating this error. Some of them can have this type of setup, and this comes in your embedded control system. So there is a control system which is embedded into the complete circuit of this device, which can automatically help reduce such errors. Okay. The next error is the circle graduation errors, which are actually based on the graduations found around the circumference of the horizontal or vertical circles. And if they are non-uniformly placed, the errors will be resulting in the observed readings of the angles. And these errors are generally small because very rarely we have such non-uniformity. And total station always use readings taken from many locations around the circles for each observations in the horizontal and vertical angle, and this will be a very good way. So we see that during the observation the whole run of the graduations are made so as to minimize the errors. So whole run of the instrument means in horizontal angle I rotate it and start from anywhere to anywhere, and in vertical angle also I try to set 0 somewhere and then take the reading. So a whole of the vertical circle is used for taking the averages to reduce the error due to circle graduation errors. And the last of the instrument error is errors caused by peripheral equipment. So we need to see that the triebacks, pummets, which are needed for proper adjustments, or the tripods or the viewing poles, sighting poles are not having adjustment errors or bubble errors, and this should be regularly checked to keep this error under control. So these are the 8 possible sources of errors for total station from instrument point of view. Is it clear to all of you? Any doubt here in the list of sources of errors for instrument related aspects? Let me know how many of you are clear with it. Please raise hands. No one is clear? Akash, Aman, Amlipur, Ashlisha.
Yes, sir.
Sorry, Ashlisha, you are raising hand now. Why? So only for 2 present here. Only for 1 of 42. It's clear. Array. What about the rest? Okay.
So we have to like read it once more. There are some wrong.
Yeah. So, but as of now, understanding wise, it's conceptually clear, na?
Yes,
Yeah.
sir.
Good. Yeah. Drop your hands. Yeah. Thank you. Now, the next source of error is the natural sources, which we know. So we know the natural sources of errors are wind, temperature, refraction, and tripods. So wind actually make the tripod unsteady, if there is very much unstable tripod setup that the total station instrument is resting on. And if you go to mountainous terrains, you might have a lot of winds. So, and high setups, even light winds can result in making the tripod oscillate or vibrate to some extent, so that the precise pointing may become difficult. So sometimes we put the instrument under windshields, or even suspending observations during some precise work when it is windy. So optical permit is very essential for such setups, and this situation in this situation, so errors can be minimized. Okay, so if it is windy, we either put it under windshields, or we try to avoid taking observations during windy situations. So next is the temperature effect. The temperature differentials actually can cause unequal expansions of various parts of total station instrument, and this can cause the bubbles to run out, which can produce erroneous observations. And again, the it is advised that extreme heat or extreme cold are to be avoided for field data collection. So next is the refraction effect. So refraction effect, actually unequal refraction bends the line of sight in the propagation of light, the spectrum or signal which is being used, and this may cause some apparent problems in the observed prism or reflector which is put on the object. And it's desirable that we keep line of sight well above the ground and avoid sites close to buildings or smokestacks, vehicles, and even large individual objects in general, which is available in open spaces. And in some cases, the observations also may have to be postponed until the atmospheric conditions are improved, so as to get less errors due to refraction. And tripod related issues, we know for conventional setups, these are the best to go for proper leveling and centering. So tripod settlement is another type of error source. The weight of an instrument may cause the tripod to settle differentially along all the three legs, particularly when it is set up on soft ground or asphalt highways or mine dumps or something like that, topsoil. So when we go for a survey job that involves crossing of swampy terrains or some other loose soil, so we should have sticks that should be driven to support the tripod legs and work at a given station completed quickly, so that we get uniformity in the mm, uniformity in the readings. So that is one aspect. So stepping near a tripod leg or touching one of the tripod legs while looking through the telescope will also have an effect on generating the error and positioning the bubble and the crosswire along the line of sight, keeping the perpendicularity with the vertical axis and parallelity with the horizontal axis. So most total stations have some sensors that tell the operator when the disorientation of any of these occur, and accordingly the operator of this instrument can be sounded. Okay, and let me see. Yeah, the last type of error. Uh, okay, so I have 8 minutes. So we can take this up in the next class, tomorrow's class, because it will take some time. So I'll stop here. I can, if there are some doubts, we can quickly discuss, and then I can stop the class. Any doubts anyone has? We can discuss now. So the errors that we discussed for total station are really of the same categories, but they have much more influence on the errors that are coming up in the observed readings or data collected, and they can be adjusted also accordingly, isn't it? Shivangi, are you there? So, hey, all of you are not attentive. Vidyasagar, Vishal, Patel, क्या हुआ? Vidya, Vidya, Siddharth, Vidya, Siddharth, none of you are there. If there is error in your audio, just text on hold. Vidya Prakash, there you go. Yashraj.
Yes, sir.
So all the effects are clear.
Yes, sir.
We will discuss the other effect tomorrow. Good. Saurav Raj.
Yes, sir.
Okay. Good. Rohit Kumar. Rohit Kumar.
Yes, sir.
Everything got any doubt or anything?
No, sir.
Okay. And Nancy
Yes, sir. No doubts.
is okay. Palash.
Yes, sir.
Okay. Good. Good. Very good. Mm, Dinesh, are you there? Why some of them are red color, some of green dots? I don't know what is the difference. Dinesh, are you there? No. Okay. Anup, Anup Singh. Anup not there. Avdut. Also. Okay, so we will take up some of the remaining components of this class tomorrow, and yeah, I'll end the class now. So thank you. Bye.
Sir, excuse me, sir.
Huh? Who is it?
Sir, yes, sir. Aman Goswami.
Hmm.
Sir, what will be the timings for the lab?
Which lab?
Mine, sir, will today only.
Like last two classes, one batch will come at 2, another will come at 3:30, like that. You will come.
Okay, sir. Okay, sir.
Hmm.
Thank
Hmm.
you.
Hmm. Hmm.
Thank you.
Okay. Okay. See you. Bye.